So here we draw the same thing that we've done before. We have our angle. It gives us an angle at 85 degrees. And then it gives us the A. What's the A side?
15.
It's 15. And this is 25. Now keep in mind, I'm just drawing this so we have a picture. I don't know if this triangle actually exists. But how do we know if it actually exists? Do we know the altitude here? The height of this triangle? We don't know the height of it right now. Okay, so we can't, well, we could figure that out. And there's a way to do that. But I like doing it this way. Let's go ahead and set up the law of sines as if we were just solving this like before. So we know this is lowercase c, that's capital B, and this is capital C. So we set up our law of sines. We go sine of 85 degrees. That's a beautiful 5. Equals sine of B over 25. And then our other one was sine of C over lowercase c. Okay, so we could solve for B, right? Right? So we would have 25 times sine of 85 degrees equals, and then we do the other one, we cross multiply with the other one, 15 times sine of B. We get that by going like this. We multiply those two, equals that. Now to find B, we divide by 15. Peace out 15. And now how do I get rid of the sine so my B is alone? Not, who said divide? No. How do you get rid of the sine? Inverse, yes, sine inverse. Or you can say arc sine. Yeah. Wait. Just let me finish. Arc sine. Actually, this time I'll write sine inverse. Sine inverse. And I have 25 sine 85 degrees over 15. Okay, what happened? It says error. Why would it say error?
It doesn't work.
It has to be less than 1 and greater than negative 1. What do you guys get right here? What, like, tell me what you get. Isn't it 1.6? So you get sine, inverse sine of 1.66, and it just keeps repeating, right? Now, what's the problem with this? Well, if you guys think back to the arc sine graph, sine looks like this, right? Right? And the 1 is right there, and the negative 1 is right there, right? The highest is negative 1. I'm sorry, the highest is 1, and the lowest is negative 1, right? Okay, now the inverse switches the x and the y's, and so when we graph arc sine, we get this. Right? And what's the smallest x? Negative 1. And what's the biggest x? 1. It has to be between negative 1 and 1 in order to work in here. And so if it doesn't work, guess what? We have an ambiguous case. This triangle does not exist. There's no triangle here. No. I drew it, but it's not correct. Technically, it goes like that. There is no triangle here. It doesn't connect. If I drop the 15 side, like let's see, this is 25 and 85 degrees. If I drop it, it's just not going to reach it. It's 15. It's not long enough. And it actually kind of makes sense when you think about it, because isn't 85 degrees almost straight up?
Yeah.
It's almost straight up. 25 is really big. All right, it's definitely bigger than 15. This triangle does not exist. Whenever you get an error, you know it doesn't exist. Okay, there's other ways to figure out if it doesn't exist, but I like this way the best because it kind of just flows with what we already know. All right, so what about this case? This is the last one. So let's draw our angle here that we're given. We have a 20 degrees. Now, these are acute angles, guys. This is a special case. Whenever you have an acute angle, the problem isn't that cute. It's a lot of work. Okay? You have to figure out if there's no triangles, one triangle, or two triangles. So far, we've seen an example where we have one triangle, and we've seen an example where we have no triangles. So guess what this one's probably going to be? Yeah. So this side is, let's see, this side right here would be 12 because it's across from the A, which is very important. And then this is going to be 31. So we have a side that's smaller than 31. Okay? But we need to know if it's bigger than the height right here. Or, yeah, is it bigger than the height? Now, don't let my picture fool you. We don't really know if this works or not. So what we can do is we can just set up the law of sines and see if it works. Okay? before, remember the triangle before? This was smaller than this one, and it was ambiguous. It didn't work. So how do we know if this one works? Well, if we do the law of sines and it works, then we know we have two triangles. You guys got it? Okay, so let's try it. So let's see. We got sine of 20 degrees over 12, and then this is going to be capital B, lowercase c, capital C, and then we have that equals sine of B over 31. And we'll set up the other fraction later. Let's solve this one. So we have 31 times sine of 20 degrees. 31 times sine of 20 degrees equals 12 times that. So we have 12 times sine of B. How do we get rid of 12? Well, you divide it by 12, blah, blah. We've done this before. Okay, how do we get rid of the sine? So we have sine -1 of 31 sine of 20 degrees over 12 equals B. All right, what'd you guys get? 62.06?
So it's 62.1.
07? Oh, and don't forget, this is approximate.
Would you round it to 62.1?
Okay, so this is for one triangle. For one triangle, we get 62 degrees here for B. Can you find the rest of the, like you can find the other angle now, right? We can find the C by using the 180 degrees thing, and then we can find that side also. And so you would have to do that. You would have to find all the rest of the stuff. But because it works, we can take this side right here and swing it that way. And it would look like this. See, this is 20, this is 31, and this is 12. You see how my new triangle works? I just took this side, it was right here, and I swung it over here. And now I have this triangle. So how do I find that angle?
Just add two angles so we already have it.
The way you would find this angle is by going 180 and subtract 62.07. That's how you're going to find your other B. So what is the other B angle approximately equal? No. It should be 100 and something. What is it? Okay, point. Okay, now you have a whole nother triangle where you have to find a whole nother C angle and a whole nother C side. C angle, C side, and this is B. Yep. So, I mean, I'm not going to finish it because I think you guys might be getting it here. Unless you guys really want me to. Should I finish it?
Yeah.
Okay. What I have to do is I have to find the capital C and the lowercase c for this triangle. And then I have to find the capital C and the lowercase c for this triangle. And then we're done. So, in the book, they give you this, which I thought was really confusing. Like, if I just talked about this from the beginning, that's confusing. Okay? So, when you look at this, I mean, it does help for some of you guys. Some of you guys who are formula lovers, you'll like this. Okay? I'm not a formula lover, though. I like understanding it. When you guys look at this, notice that there's two sections. One section has all the acute angles, and one section has the obtuse angles. The obtuse ones, they're beautiful. Look at that. You either have none or one. Okay? If you do law of sines and it doesn't work, then you know that it's none. If they give you an obtuse angle. Okay? But here they also say if you know that A is less than B, then you know that it doesn't exist. There's none. Okay? And what is A? Crystal, you remember you said that earlier. What is A? A is the side that is opposite the angle they give you. So see, they give you the capital A. If they give you capital A is the opposite the side of the angle they give you. Well, that sounds really confusing. That doesn't sound really nice. But over here, the acute angles have more options. You either have the ambiguous case, where you have no triangle, or you have a right triangle, where you only have one solution. Now, this I wouldn't worry about because that'll be automatic when you just do the law of sines. Okay, these two right here are automatic. You'll get it. And how do you know which one's which? Well, if A, the side they give you, is bigger than the other side they give you, then then you know there's just one. If the side they give you is between the length of side B and the height, then you know that you're going to have 2. Okay? That's what this one says, but I don't know. I still think it's more confusing than the other way.